right? And we're going to be going, I don't want to say we're going around in a circle, but I'm going to try and explain as we're going how statistics actually ties together with probability. And these two things kind of work together. So once we're done doing statistics, we're going to do probability. Okay. Because they kind of work together. Let me just double check. Give me a thumbs up or a thumbs down. Have you guys heard of an actuarial scientist? Do you guys know what an actuary is? Thumbs up. Thumbs down. Okay, Hulani says yes. Nerisha, no. Princess, no. Yes. Didi Malo, no. All right. So if you ever want to make a ton of money, and if you are really, really good at maths, becoming an actuary or studying actuarial sciences, let me actually write out the whole word. Actuarial sciences. Okay. What actuarial science actually means, or what they actually do, is they take raw, unprocessed information and they turn it into usable data so that they can make predictions in the future. Okay, so let's say, for instance, at the moment, there are a lot of floods. Let's say, and I'm just going to make up a dumb example, right? Yes, like computers, pretty much, right? But computers can't do all the work because, you know, there's certain things that humans still need to do. All right. So let's say, for instance, in South Africa at the moment, there are a lot of floods. There are many, many floods everywhere, right? And let's say, for instance, in KZN, where I live, we have a lot of agriculture, right? And then we find that the floods are located in areas where they grow a lot of meal, like grain, like mealie meal grain, and where they grow wheat. Right. Now, as an actuary, what I'm going to do is I'm going to now research companies that make grain and wheat and see how the floods have actually affected them. Right. And I'm going to take all of this information and I'm going to take it to my investor and I'm going to say to an investor, listen, I don't think it's a good idea for you to invest in, let's say, for instance, sandwich shops. Like, let's say, for instance, an investor was like, I want to start a sandwich baron. I want to open a sandwich baron. As an actuarial scientist, I'm going to say, don't do that. There have been floods and the grain and wheat is gone, which means the little bit of grain and wheat that is left is going to cost a lot, which means in order for you to buy bread to make sandwiches, you're going to have to charge a lot for your sandwiches. And people are not going to buy. You're not going to make money. Okay, is that making sense? It's a bit of a dumb idea, but so it's a bit of a dumb example, but are you guys understanding what Ma'am is saying? Yes, Narisha. So it's almost like you're a fortune teller, but you're an informed fortune teller. Do you understand what I mean? So, like, for instance, at the moment, okay, the Olympics are happening in Paris, right? The Olympics are happening in Paris, and you would think, what a great idea for me to go or to invest in a lot of the companies or a lot of the tourist attractions in Paris, only to find out that at the moment, if you watch the media, you're finding that people don't want tourists in, or French people don't want tourists in Paris. Spanish people don't want tourists in Spain. And now imagine you putting money into the tourist market in Paris, and then people are chasing tourists out of Paris. You're not going to make your money's worth. So that's what actuarial scientists do. They take data and they analyze it and they use, yes, exactly, Narisha. It's such a bad story at the moment. So imagine if you were like, I'm going to give the tourist, I'm going to invest in the tourist department in Paris. At the moment, when people are doing number twos in the river, in the River Seine at the moment, no, that's not a great idea. You see what I mean? So actuarial scientists, they do the research and then they make informed decisions for investors so that investors can make good money decisions. Okay, and that's what they do pretty much. And guys, when I tell you, it's a difficult degree to study, but once you have it, you will make bank. You will make so much money. Okay. Because you could literally make people millions across the world if you give them the right information and you help them to make the correct type of investments. Oh, are you talking to me, Gift? I don't really like the corporate space. And I love holidays. And that's the only reason I'm a teacher. I love holidays and I don't like working with other adults. Adults aren't exactly the nicest people. I'm just going to put that out there. I know I'm an adult myself, but adults are kind of mid. I'm not a fan. I'm not a fan of adults, so I'd rather work with kids. And I really love education. I think I'm a good teacher. I don't know. I really like teaching. You know, it's a calling. All right. Okay. That's beside the point because Gift is now making me bad for making me feel bad for not being an actuarial scientist. Children are very scary, Narisha. No, you're not. You guys are not. I personally think that kids are very, very, like, they're the nicest people. They bite. Okay, I'll tell you what. I don't know who Soupy Swaps is, but Soupy Swaps, I've never been bitten. I've never been bitten. Maybe that's why I don't teach primary school. I only teach high school because I don't think primary school, or high school kids really go around biting their teachers, which is a nice thing, which is a really nice. Last year, no, okay, I'm so glad that this is happening online because no, and yeah, Abu, I'll tell you what, I'm lucky enough to teach at a school where those kinds of things are not tolerated. So I can tell you now the number of fights, I think, per year at our school. Maybe. Sure. Okay. I'm not sure what happened there. Someone else is sharing their screen, and that shouldn't actually happen. So I will try and figure out exactly what's gone on. But I need to just go and check okay. I just needed to uncheck that. All right. Okay. That's fine. That's fine. I figured it out. That's okay. Let me just see. That was around 6:13. So we'll just need to crop that out. All right. Okay. So let's just get into the nitty-gritty of what we're doing today. All right. If you want to become an actuary, that's something that you can do. All right. Okay. So let's talk about what data is. Does anybody who can tell me what is data? Does anybody know what is data? And I don't mean like MTN, Vodacom, Cell C. Yes, okay. Abu, correct. That is the correct. That's it, Didi Malo. Beautiful. Yes. Oh, my goodness. Just lovely all the way around. Excellent. All right. So I'm going to go with every single one of those. I think the best one that sums it up properly would be the raw, unprocessed data. All right, I like that one. Or raw processed unprocessed information, right? So it's just information that we collect. It's just been collected. We haven't done anything with it. We haven't put it together. Correct. Sure, you guys are super smart. Maybe you all should become actuarial scientists. Well done. Okay, right. It's raw unprocessed information. Now, what we do with this raw unprocessed information is very important because once we take this information and we make it tell us a story, so we group it and it tells us a story, right? What we do with that information is we use that information to make informed decisions. Okay, we use that information to make informed decisions, like when we decide what kind of stock to invest in, or when we decide not to open a particular type of shop because we're not going to be able to get the raw materials. Okay, I'll find a number for you, Abu, and I will tell you at the end of the lesson, but it's a lot, I'll tell you. Okay, right. So all of this information that we're taking, we're using that to come to a conclusion that is actually very helpful. Okay, so we're going to be learning about different types of data, and that's basically what we're going to be doing today. All right, now just to give an example of the way that we would use data in a way that would help us. Like, let's say, for instance, I told you it's a lot. Okay, let's say for instance, guys, help me out. I don't know. My side of TikTok looks very different. What do you guys? Who's the most popular person on TikTok at the moment? I don't know. You guys will have to help me. I don't know. The other class said it was Tyler. Is it Tyler? King Chris? I don't know who King Chris is. Right. Okay. So I'm going to assume. Okay, let's go with King Chris. I don't know who King Chris is, but I'm gonna take King Chris. I hope you guys are with that information here. All right. So King Chris. Now, when you guys log into TikTok, right? You're all, let me just double check. How old are we? I'm gonna assume we are all either 15 or we are 16 or we are 17. Okay, Gift is 18. So Gift, you're definitely the outlier here. Okay. Okay. Oh yes, Mr. Beast. We could say that, Mr. Beast. All right. So because let's use Mr. Beast. Let's see, because not everybody's really into it, man. But I know everybody knows who Mr. Beast is, right? So Mr. Beast has content, right? So let's say, for instance, TikTok is taking all of this information and they are and Charlie D'Amelio. I thought it was Charlie D'Amelio. I won't lie. I don't even know who she is, but I've heard her name enough times to know that she's popular. Okay, so let's say, for instance, there's a 16-year-old who gets a new phone. They are downloading TikTok for the first time. Now, the TikTok algorithm needs to choose what the first thing they're going to show the 16-year-old teenager is, right? Now, imagine as a teenager, you open, or as a 16-year-old, you open TikTok for the first time, and the first thing you see is News 24. That's the first thing you open and you see. Does that make sense? Like, I mean, come on now, right? Obviously, the idea of TikTok is to keep you engaged, right? Now, if it were me, and I had downloaded TikTok and the first thing I saw was a News 24 video, I would definitely be like, oh, this is right up my alley. I love current affairs. I love news, right? Imagine, yeah, if you were to open it and you saw that, the first thing you'd be like, this app is for old people. And you close the app and you delete it, right? So yes, correct. So it would start you off with something that is popular for 16-year-olds. And then the more you scroll, the more information TikTok takes in, and that informs the decision that TikTok will make about what it will show you next. All right, thumbs up. Is everybody understanding where ma'am is going? Yes? Lovely. So when we take this raw, unprocessed information, we are collecting it, we're grouping it. So we're taking all the information we have, we're grouping it according to 16-year-olds so that the next time a 16-year-old opens TikTok, they're not bombarded with things that old people would like. The first thing that they would see would be something that they would like, and that keeps them engaged. And yes, they do that, right? But you're going to get older Gift, and your likes are going to change as time goes on. So the more you scroll, the more information they pick up. Okay, like let's say, for instance, you like gaming, right? Would you really like it if the only thing that they showed you about gaming was Subway Surfer? Imagine just all the games that you're seeing is Subway Surfer and Candy Crush. No, of course not. But my mom would love that. My mom plays Candy Crush all the time. So she would love seeing Candy Crush and people telling her tricks on how to do better at Candy Crush and those kind of things. She'd love that. But you would want to see something like an actual gamer actually gaming, so that would make it a little bit more interesting. Okay. All right. So that's the kind of thing that we're doing with the information. We're using the information we've got to make informed decision about what comes next. And Diswa, Candy Crush is addictive. And I've deleted it since because I never got any work done every time I played Candy Crush. Okay, it's addictive. It's problematic. It's very problematic. Okay, so let's talk about the different types of data we get. We get qualitative data and quantitative data. Does anybody know the difference between qualitative and quantitative data? Okay, Narisha says no. Didimala also says no. Okay, we've never seen this word before, not a clue. That's okay. All right. Okay, let's talk about it. Let's talk about it. So, qualitative data is, let's say, for instance, you go to Typo, for instance, right? And then once you're done, Typo normally sends an email and they'll be like, rate our service. And then they'll ask you something like, how was the service? Was the service excellent? Or was it good? Was it okay? Was it meh? Or was it bad? Do you see how the information that I'm collecting is made up of words? Yes, it's made up of words. So qualitative data is information that we get that is made up of words. All right, like let's say, for instance, everybody pop into the chat your favorite ice cream flavor. What's your favorite ice cream flavor? Strawberry, mint chip, tin roof, Oreo, strawberry or caramel, vanilla. Do you see how you are all giving me words as answer? Not yet, Lerato. Hello. Lovely to see you. We haven't started with finance yet. Okay, exactly. So the information that we're collecting is made up of words, and that is qualitative data. It's giving us an actual word as data. All right. Now, quantitative would be something like me asking, how many hours a day do you spend at school? Drop your answers for me in the chat. How many hours a day do you spend at school? Abu, you can't say 28. There aren't even 28 hours in a day. Right. Okay, so we've got 6 hours, 7 hours, 8 hours, or Hulani, who is just a beast of a student, 10 hours, right? Even me as a teacher, I don't spend that many hours at school, right? So quantitative data is when we collect words as an answer, right? So 8 hours, or 7 hours, or 6 hours, or 10 hours. So that is quantitative, like quantity, how much. That is quantitative data. Thumbs up. Does everybody understand the difference between qualitative data and quantitative data? I mean, yes, we could, Khulani, but I don't really do sport. So sport is not for me. I don't do sport at all. Okay. I coach debating, but I don't really do sport. So I don't know. Maybe it counts. Okay. So that's the difference between qualitative and quantitative data. Okay, Andiswa? Okay. Qualitative data is when we take words as information, and quantitative data is when we collect numbers as information. Okay, making sense? Qualitative data, how do you rate our service? Excellent, good, okay, bad. That is qualitative. How many hours do you spend at school? 6 hours, 7 hours, 8 hours. That is quantitative. Okay, we happy? Okay, lovely. Okay, now I want to add in here, I want to add a caveat. I want to just say in here that I can actually take qualitative data and I can change it into quantitative data, right? Okay, and this is how. Let's say, for instance, we're talking about streaming platforms, right? Now, there are only a handful of streaming platforms, right? There's Netflix, there is Disney Plus, there is Hulu, there is Showmax, there is, I don't really know any others. There's Prime Video. Let's just say we're just going to stick to these 5, right? So I want you guys to drop in the chat for me. Which streaming platform do you use the most? Okay, I will also add a column for, okay, let's add in YouTube. Let's add in YouTube. We'll add in YouTube, and we can add in TikTok as well. Okay, which streaming platform do you use the most? Okay, I'm seeing Showmax. I'm seeing, okay, all right, that's a lot of information. I'm gonna have to count. Okay, so now if I go and I look at the information, right, I'm gonna count the number of Netflixes. So there's 1, 2, 3, 4, 4, right? So for Netflix, we've got 4, right? For Disney Plus, I saw that we have 2. Hulu is 0. Showmax, I saw 1 person. Prime is 0. YouTube, I saw 3 people. And TikTok is probably a lot. Let me have a look again. Okay, 1, 2, 3, 4, 5, 6, 7. All right, so TikTok is 7 people. So can we see how ma'am has taken qualitative data and she's now turned it into quantitative data? Thumbs up. Everybody okay with that? I was like, ma'am, add illegal websites. Like anything with a .io at the end or a .to. I know all those sites. Or .ch. No, we're not adding those in there. All right, so I can take qualitative data and turn it into quantitative data. Oh my God, Gift, that's the one I use. That's the one I use. Okay. I think we're all using the same one. All right, so that's the difference between the two. Qualitative, we're using words, and quantitative, we're using numbers. All right, now let me ask, give me a thumbs up or a thumbs down. Do we have a difference between discrete and continuous data? Yes? Okay, I'm saying no. Abu says yes. Abu, do you want to tell us what the difference between discrete and continuous data is? I can tell you now, discrete data doesn't mean that it's a secret. That's not what discrete means, because that's what somebody in the other class said. They were like, discrete data is discrete. No, no, it's not. It's not that kind of information. All right, let's do this. Let me ask everybody. Okay. I need to make it something that isn't too hard. Let's say, everybody drop your shoe size in the chat. Let's drop your shoe size. Okay, I've got a 5, I've got a 9, I've got a 1, I've got a 12. Okay, sheesh, Didimalo, I need to ask Didimalo, is it 12 as in 12 or is it 12 as in 12? Which 12 is it? I see a 16, so clearly we're not even buying shoes in the country. We're having them made. We're having them made outside. I know some of these sizes are, it's insane. It's insane. Okay, all right. So discrete data is exactly what you guys have just given me. So if I ask you guys for your shoe size, you're all going to say 7 or 8 or 5 or God forbid 12 or 13. My brother wears a 13 or 4, right? Now, if I asked you for a shoe size, are you ever going to come to me and say, my shoe size is 7,35? Will you ever get 7,35 as a shoe size? Nope, we're not going to get that. That's not discrete data. Discrete data, okay, we're not talking about things like custom-made shoes. Like if you walked into a store and you asked, and you're like, I want to buy a pair of shoes, and the store clerk said, okay, that's great. What size are you? You're not going to be like, I'm size 8,44. Like, it's not going to make sense. Okay, so discrete data is information that's already kind of packaged for us. Like, let's say, for instance, I ask you guys, how many siblings do you have? How many brothers or sisters do you have? Pop your answers in the chat. Geez, Didimalo 5. You know what? Didimalo's just living a hard life. Hi, Bo. Princess, how do you have 3,4? How do we have 3,4 of a sibling? I want to know, what does the 4 brother or sister look like? I need to know what the 4 brother looks like. Is it? I also grew up in quite a big family, but yeah, I didn't know, guys. I can't. Yo, Too many children. Oof. C. All right. So when we look at discrete data, it's a number that's already packaged for us because I'm not going to have 3,6 brothers and sisters. I can't have 3,6 siblings. That's not possible. It's not a possibility. I can't have comma 6 of a siblings. One of your siblings is in this class. Why did I not know that? Oh my goodness. I never would have known. Hello, siblings. Lovely. Wait, what? This is so cool. I didn't know that. So did you want brothers? I feel like they're lying to me now. I feel like they're just pulling my leg. Yeah. I don't trust you. I don't trust you no more. Okay, good. All right. Now, is it? Okay. It's so lovely to meet you guys. It's so lovely to meet you guys. It's so cool. I should let the other teachers know. That's so dope. Okay. All right. So here's the next thing. That is discrete data. Discrete data is data that's going to be whole numbers that have already been nicely packaged for us. And I include shoe sizes because I know somebody's going to say, but ma'am, you can also get a 7.5 shoe. That is very true. But you're not going to get every other size in between 7.5. So you're not going to get 7,4 and 7,3 and 7,2. You're either going to get a 7 or a 7.5 or an 8. That's the only sizes that you get. You don't get anything in between those. Okay. All right. Now, here's the next thing. I'm going to ask you guys to drop your height in meters in the chat for me. I'll go first. I am 1,75 meters tall. What about you guys? Hey, same. Same. So both Abu and I is 1,5. Didimalo, there's no way on this planet that you're 5 meters tall. You would have to be taller than the building that you're living in. Okay. Gift, I need you to convert that to the metric system, please, because we don't use imperial systems in South Africa. Okay, so I'm seeing a 1,62. I'm seeing a 1,64. I saw somebody say 1,50 meters, right? 2 meters. I have a couple of kids in my class who are 1 meter, who are 2 meters tall. Okay, yes, so we can say 2,0 meters. Do we see how everybody's height, it is very tall. It is quite tall, actually. Okay, do we see how everybody's height is different, right? And it's not easily packaged. The gift is 1,73 meters. It's not like a distinct given number. Oh, shame, Narisha. That's okay. 1,21 meters. We'll add it. There we go. We'll add it in there. It's okay. It's okay. There's nothing wrong with that. It's fine. It's just height. What are people going to do? Dynamite comes in small packages. Okay. I will gift. No, gift. Be nice. Be nice. Be nice. That's not okay. That's not okay, gift. All right. Okay. So can we see the difference between discrete data and continuous data? Continuous data is going to be different all the time. We're not going to get a set data for every single person. Thumbs up. Are we seeing the difference? There's too many different answers for each of them. Whereas if we're asking about siblings, you're going to get 2 or 1 or 3. You're never going to get a decimal. But when we talk about continuous data, we're talking about things like height or weight, or if we are measuring the length of, let's say, for instance, we're measuring the length of people's arms, right? You're not going to be able to get 2.5 siblings. Okay, you either have a full sibling or you don't have a half a person in your life. Okay, and that's the difference between discrete and continuous. Narisha, the baby inside the womb is also a full baby. Okay, it's a full baby. All right, Asanda saying, how do we put it in words? I can try, Asanda. It's quite difficult, I'll admit. Okay, so we can say discrete data is, geez, how do we put this? Discrete data is data that stays the same. Let's put it that way. that stays the same, or we can say that stays whole. That stays the same or whole. Okay, it will always be whole numbers, or that stays the same, data that does not change, right? Continuous data is varying data. Okay, varying data, it will always be different. Okay, does that help? Okay, excellent. Okay, so it would always be data that's different. All right, now I want us to talk about one or two more things before we continue. Okay, I want us to talk about, oh my goodness, things from last day. Okay, I want us to talk about the difference between a population and a sample. Okay, now let's say, for instance, right? It's not, I promise. It's not difficult at all. It's actually the easiest section in the whole of matric, in the whole of grade 10. Right. Yes, it is, Andiswa. This is just an introduction. Okay. All right. So let's say, for instance, at your school, there's going to be like one of those markets where you guys can sell things and all of that kind of stuff. Right. Now, if I had to think about, yes, we're actually going to do tally tables today, Narisha. We're going to do tally tables today. Okay, let's say, for instance, now I want to collect data, right? If we're going to be doing, like if we're going to be selling, let's say, for instance, cool drinks at the market at school, right? Would it be in my best interest to go to the internet and type in, what kind of drinks do teenagers like? Is that going to help me? Yes or no? Okay, the question that I'm asking isn't really like that. Okay, let me put it this way. Let's say, for instance, if I type it in the internet, I type in, what is teenagers' favorite drink, right? What is teens' favorite drink, right? And the internet says to me that it is Prime. The internet says Prime is the favorite drink. But you get to your school and you find that most of the kids at your school don't drink Prime. They don't like Prime, right? They would rather have Coke. They would rather have Coca-Cola, right? So in this case, what I need to do is I need to differentiate between the population, which is all teens, versus the sample, which is teens in my school. Okay, because that will help me make a better informed decision. All right, thumbs up. Is everybody understanding what Ma'am is saying? Right? Population would be all the teenagers out there, right? But the sample would be the teenagers around me, the teenagers that I need to now sell things to. Not all the teens in the world. That's great that all the teens in the world like milk or water or fruit juice, right? But the kids at my school, where I'm going to be selling drinks, they like Coca-Cola, or they like Sprite, or they like Fanta. Exactly. So at Abu's school, they like Monster. So imagine you now go and you buy all of this Prime, and then the market comes and you've bought all of this Prime because the internet said Prime, and then you can't sell anything because you're not catering to the kids in your school. So there's a difference between a sample and a population. Population would be all the people, and the sample would be the small bit that is at your school or something along those lines. Another example would be the difference between trends in South Africa, the trends in South Africa versus the global trend. Okay, those two things are going to be completely different, right? Because even though we listen to American music and all those things, if somebody starts talking about biltong, the Americans are not going to understand what we're talking about. The Chinese are not going to understand what we're talking about. The Australians are not going to understand what we're talking about. Biltong is specific to South Africans. Okay. Thumbs up. Is everybody understanding what ma'am is saying? Okay, so there's a difference between a sample and a population. We're going to find that we're using a smaller sample because even if we are trying to find information, we can't go and interview everybody in the world. We can only interview the people around us or gather information about people around us. Yes, Narisha, it's called jerky and it is disgusting. I didn't like it when I lived in Florida. I did not like jerky. It was like the knockoff version of biltong. It's a no from me. It's a no. I didn't like it. Okay. All right. Okay. So that's where we're going to start today. Now we're going to look at how to group the data as we're going with it. And we're going to start looking at frequency tables. Now, can anybody tell me, what does the word frequency mean? What does frequency mean? Anybody? Not particularly, Abu. It's just different. It's just different. Okay, anybody? Yes, okay. F is equal to 1/t. That is true. That is very physics minded. I see it. Okay, consistency, number of pulses per second. Yes, that's a very scientific, like that's a very physics kind of saying that. Consistency, Princess, I'm not sure about consistency. Okay, all right. Let's say frequency is how often does something occur? Okay, how often does something occur? And for those of you who are saying 1/t, that's exactly what it is actually. So if we think about it, let's say, for instance, let's take revs. Like, you know how a car revs, right? When somebody tells you that my car does 2,000 revs. Have we heard this before about cars? Yes? We've heard this about cars before. Okay, Princess says no. I don't think girls would know that much. But let's talk. I'll give you a little bit of a background, into what this actually means. So when we are looking at vehicles, right? Inside a vehicle, there are many, many moving parts, right? So in order for your tires to move, there are pistons inside the car that also need to move tinier, smaller cogs, right? So now if this cog goes from there, if it moves all the way around, what do we call that? When something moves from one point all the way around, what do we call that? Rotation. I'm looking for the proper word. When it goes from there all the way around. That's correct, Princess. It's a revolution, right? It's a revolution, right? So when we say 2,000 revs, the revs part actually means revolution, which means when you are trying to move your car, this tiny little clog or this tiny little part there, that tiny little cog goes around 2,000 times per minute. That's what a rev per minute means. Okay. And it moves really, really fast because the small thing is connected to something bigger, and then the small ones help the big thing move. You understanding what ma'am is saying? Just kind of like on a bike. Have you guys seen how a bike works? So if you're sitting on a bike, this is your pedal here. These are your pedals. There's the other pedal on the other side. When you do a full revolution, your tires also do a revolution. Your tires also do a revolution. So when we say revs, we're talking about the number of revolutions that the thing goes around. So when you go around once on your tire, or maybe you go 1, 2, 3, 4, then your tire moves once on your bicycle. Right. And then you go again, 1, 2, 3, 4, and your tire moves 2 times around. Okay. So yes, humans do build these kinds of things and they're very smart about it. And that's what we talk about when we say frequency. How many times around do you need to go? So when we look at information, when we're talking about frequency, we are talking about how many times does this thing occur? How many times does this thing happen? Thumbs up. Everybody okay with that? I'm going to give you guys a very, very simple example. It's not going to be this complicated, I promise. Okay, it's not going to be this complicated. Let's look at this example over here. Okay, there we go. There's your tally, Narisha. Are we happy? There's the tally. Are we happy? There, we've got a tally. Okay, so when we've got information, the way we can group the information is to see how many times something shows up. We're calculating the frequency. So let's read this, this example over here. It says, Amanda collected 20 leaves and wrote down their lengths in centimeters. So here is my first question. Is this qualitative or quantitative data? The data that we've been given, qualitative or quantitative? Correct, Abu. Lovely. It is quantitative because we're not collecting we're not collecting words. We're not taking words and putting them into numbers. We're taking numbers. So this is quantitative data, right? My next question is it discrete or continuous data? Be careful, Abu. Is it continuous? Okay. I'm getting two different answers. Somebody's saying continuous, somebody else is saying discrete. So I'm going to have to ask, which one is it and why? If you say continuous, tell me why. And if you say discrete, tell me why. All right. Okay. So for those of you who are saying continuous, look at the type of data we've been given. Look at the type of data we've been given. Is it going to give us a decimal at some point? No, we're not going to get a decimal. Okay, we are only going to get whole numbers because the way that Amanda has actually measured the leaves gives us whole numbers. So is it discrete? Is it continuous? It is discrete data. It's discrete data. And guys, this is very important information. It's going to come up in your quiz on Wednesday. So bear in mind, very, very important, it's going to come up. Okay, so when we organize the data, here's what we're going to do. We're just going to count how many of them come up, right? Because when we, and I didn't finish the statement, how often does something occur, right? So when we're counting here, we're going to start by saying, how many 2-centimeter leaves do we see? How many of them occur? Just one. There we go. Tally 1, and also frequency is 1. Okay, how many 3-centimeter leaves do we have? Just one. So 1 there and 1 there, right? How many 4-centimeter leaves do we have? 1, 2, 3, 4. We have 4 of them. 1, 2, 3, 4. The frequency is 4. Guys, I'm going to be completely honest. I hate tallies. They are the most boring thing. It makes me feel like I'm back in primary school, and it's not for me. It's not for me, but I'm just going to do it because it's here and it's part of the syllabus. We have to do it. Okay, how many 5-centimeter leaves? 1, 2, 3, 4, 5. So, oh, I missed 1, 6. There's 6 of them. Okay, so I have to go 1, 2, 3, 4, 5, 6. The frequency is 6. Okay, then we go, how many 6-centimeter leaves? 1, 2, 3 of them. 1, 2, 3. 3. How many 7-centimeter leaves? 1, 2, 3. 1, 2, 3. A frequency of 3. And for the 8-centimeter leaves, there's 1, 2, 2 of them. All right. So, oh, guys, come on now. I mean, gift, it's free marks. It's free marks. Okay, yes, it's free marks. I don't like it, but it gives us free marks. Okay, so here we've taken the information that was just raw and unprocessed, and we've grouped it in a way that makes it easier. Now, I have one last question before we continue. Is this information that we've been given, is it a sample or is it a population? Sample or population? Correct, Narisha. It is a sample. Well done, Didimalo. Of course, it's a sample, right? We can tell that it's a sample. But if we are looking at the sample, if we just go off of the sample, we can make an informed decision. Now, let's say, for instance, Amanda is a grade 3 teacher, right? And she's going to do an exercise with her grade 3s. Which size of leaf shows up the most? Which size of leaf shows up the most? 5 centimeters, correct. The 5 centimeter leaf shows up the most, right? That's the one that shows up the most of the 20. So when she sets a task for her kids, she can say to her grade 3s, go outside and find a 5 centimeter leaf. And she can say this because when she was collecting leaves, she realized or she noticed that a lot of the leaves that she found were 5 centimeter leaves. So if she sends her grade 3s outside to go find a 5 centimeter leaf, there's a very high chance that they're going to be able to find a 5 centimeter leaf. Thumbs up. Is ma'am making sense? Yes? Lovely. Good. So we're taking the information that we've been given and it's helping us to draw a bigger picture that helps us to make informed decisions about what we can do in the future, just like Amanda over here and her leaves. All right. Okay, let's look at something else. I want us to look at a different one. Okay, we're going to look at this information over here. Okay, I see what's happened. All right, it says here, the following data set lists the midterm scores received by 50 students in a chemistry class. Right, now, if we look at the difference, yes, and that's the thing, Abu, that's exactly what I wanted you to do. Okay, to come to that conclusion. If we look at the difference between what we did with Amanda, do you see how Amanda's ones is just 2 centimeters, 3 centimeters, 4, 5, 6, 7, 8. Now, if we had to take the same information, would it be worth our while to write who got 20%, 21%, 22, 23, 24? Imagine having to draw a table or a frequency table where we would have to draw out every single value. It's pointless. It's not going to help us. So what we need to do in order to better evaluate the information is we need to write it out in intervals. And that's it, Princess, exactly that. We can write it out in tens, right? We call them intervals. We call them intervals. And I'm so sorry, Narisha, I don't think I'm going to do the tally anymore. I'm just going to go straight into frequency. Okay, so we can say, let's look for everyone who got between 20 and 30%. We're going to count those people. Then we'll count everyone between 31 and 40%. And then we'll count everyone between 41 and 50, everyone between 51 and 60, everyone between 61 and 70, 71 and 80, 81 and 90, and 91 and 100. Okay, and we can count up all of this information, right? Okay, right, we can count up all of this information, and I'm actually going to cheat because I already did this in the other class. So I'm going to go cheat and get the answers because I don't think I want to sit here the whole day and try and figure out what these answers are. 2, 2, 3, 2, 6. Okay, ma'am is cheating. I'm so sorry. 2, 2, 3, 2, 6. Okay. Gift, don't be judgy. Don't be judgy. Gift is judging me so hard right now. And then 9, 14, 12. 9, 14, and 12. All right. Yes, exactly, Narisha. Work harder, not like work smarter, not harder. Exactly. Yeah. All right. So this is all of that information processed. All that raw information has been taken, and we are now looking at it. Now, as the chemistry teacher, right? If I look at this information, was this a hard test? What is it? Was it a difficult test? Yes or no? Gift says yes. Let's look at the information that we've been given. Was it a difficult test? I would say no. How? Why would I say no? Why would I say this was an easy paper? Why would we say that it was an easy paper? Okay, apart from the fact that 14% got that much, but a lot of people, most of the people in the class got high marks, right? If we count up the majority of the kids in the class, I mean, this is 12, this is already 26, this is 35. So 35 out of the 50 students got between 71% and above. 35 of the students, right? So the other 15 over here, right? Now, as a chemistry teacher, you now know that, first of all, this wasn't a difficult test. And second of all, the kids who got really low marks definitely didn't study and definitely didn't apply themselves. So now you know you need to go to speak to those kids who got lower than 17. You need to tell them, guys, it's time for you guys to step your game up. Okay, so do you see? I just want to make sure, thumbs up. Are we seeing how when we organize the information, it tells us a story and it helps us make informed decisions about what needs to come next? All right.